Hello, this is section 1.1 of Math 18. Today we're looking at an introduction to integers. So we have two objectives for today: to use inequality symbols with integers and also to learn how to simplify expressions with absolute value. So here's the set of integers. The set of integers includes negative integers to the left of 0, starting with -1, -2, -3, and so on, 0 itself, and positive integers to the right of 0, 1, 2, 3, 4, and so on. So the set of integers is the set of whole numbers and their opposites. The ones to the left of 0 are negative integers, the ones to the right of 0 are positive integers. In math, we can also use any letter of the alphabet to be used as a variable. So variable is just, sorry about that. A variable is just any letter of the alphabet that stands for a number. So we can use those, we're going to use those a lot in mathematics. We have two inequality symbols that we're going to be looking at. We have less than, okay? Less than is going to point to the left, and that's the way that symbol goes. So anytime that one term is to the left of another term, it's always the one that is less, okay? It's smaller. So if A is to the left of B on a number line, A is less than B. If A and B are on a number line and A is to the right of B, then we can say that A is greater than B, and that symbol is pointing to the right. So yes, if you learn the alligator's mouth eats the bigger number, that still holds true, but at some point you do need to know the difference between just the less than symbol and the greater than symbol. So just remember, the less than points to the left and the greater than is going to go pointing to the right. So remember left and less. That'll help you there. Look at these two examples. We have -2 and 1. Well, if you look at the number line, -2 is to the left of 1, so -2 is less than 1. And then on the second one, we have 3 and 0. 3 is to the right of 0, so 3 is greater than 0. Now, we also have two other inequality symbols that are called is less than or equal to, or is greater than or equal to. The important part of these two symbols is the word or. Okay, look at these two examples. -5 is less than or equal to -1. Most people are like, okay, no problem, because -5 is smaller than -1. But a lot of people have trouble with this second one. -5 is less than or equal to -5. They're like, well, that's not true, because -5 is not less than -5. But it is equal to. So because of that or statement right there, that's what makes that a true statement. Now let's look at using less than, greater than, or equal to compare these integers. The important thing to remember when you're doing these problems is that you must read them from left to right. So a lot of people just look and yell out the larger number. What you need to do is read the problem from left to right to see what symbol goes in between the two numbers. So -5, is it less than, greater than, or equal to -12? Well, -5 is to the right of -12, so it's going to be greater than. 6 and -3, 6 is positive, -3 is negative, so 6 is definitely greater than -3. And then down here, -9, is it less than, greater than, or equal to 0? Well, it's a negative number. All negative numbers are smaller than 0, so -9 is less than 0. Now this next one, when they're both negative like this, it's kind of hard. But think about your number line. Picture it in your head. You'd have -35 would be to the left of -33. It would be further to the left, which means it's going to be less than. Remember, left and less. -35 is less than -33. All right, so try these. Pause your computer, try them, pause the video, and try them, and then I'm going to go over the answers. So, number 1, -5 is going to be greater than -11 because it's to the right of -11. -7 and -6, well, negative versus a positive. Negative is always smaller, so that's going to be less than. Same thing with number 3. All negative numbers are always less than 0. So -18 is less than 0. And -32 and -36. -32 is going to be to the right of -36, so it's going to be greater than. So hopefully you did okay on those. All right, so now we're going to look at the idea of opposites, and then we'll also talk about absolute value. So two numbers that are the same distance from 0 but on opposite sides of 0 are called opposite numbers. Okay, they can also be called additive inverses of each other. Okay, I will mostly just call them opposites because that's easier. And it just makes a little bit more sense. So if we're talking about a positive 5, the opposite of 5 would be negative 5. Pretty simple. The opposite of negative 5 would be positive 5. So if we asked you in plain old English, find the opposite of, then that's not too hard. But in math, of course, we're going to make you use symbols. And so here's how we ask you to find the opposite of something. Look down here where you have the opposite sign in front of the parentheses with the 2. That's saying find the opposite of 2. So that would be negative 2. And then the second one, the opposite of negative 2 would be a positive 2. Now some people say, well, why can't we just think of this as like a negative times a positive? You can. We just haven't even talked about multiplication yet. But it is the same exact thing. So you can either think of it as multiplication with a negative, or you can think of it as the opposite. Either way works. Okay, so let's look at these problems. It says given A is the set of negative 12, 0, and 4. Find the additive inverse of each element of set A. Now remember, the additive inverse is the same thing as the opposite. So if they ask you that in your homework, don't freak out and think, oh my gosh, what is that? It's just the opposite. So the opposite of negative 12 would be 12. Okay, now what about 0? Is there any such thing as negative 0? No, you wouldn't tell somebody you have negative no money. That doesn't make any sense. That would be when you're really broke, okay? But just 0, the opposite is just 0. 0 is the only number whose opposite is itself. And then 4, the opposite would be negative 4. So there's your answer for number 1. Now look at number 2 here. It just says evaluate. So the sign on the outside is telling us to find the opposite of negative 7. So that would be positive 7. The opposite of 14, a positive 14, the opposite would be negative 14. And this last one, the opposite of 8 would be negative 8. Now, the next operation we're going to look at is called absolute value, okay? And the absolute value of a number is the distance from 0 to the number on the number line, okay? So, whenever you have absolute value, it is always denoted by these two straight up and down lines. That's the absolute value symbol. So basically what the thing here is, the whole idea of absolute value is that it's distance, and distance is always positive. Okay, if you were to walk backwards across a room, but you went back and measured how far you walked, it would still be a positive distance. They don't have negative numbers on, rulers or on yardsticks. So if any of you saw the movie Ferris Bueller's Day Off, at the end of the movie they're trying to put the car in reverse to take all the mileage off. If you remember that part, not happening. That distance is positive. It's there, okay? So that's what they're talking about there with absolute value, that it's always distance. So the answer is always going to be positive. So look down here. It says the absolute value of a positive number is the number itself. So basically positive, okay? All right. And then the absolute value of a negative number is the opposite of the number. Basically positive, same idea, okay? The absolute value of 0, it's just going to be 0 because 0 is not considered to be negative or positive. It's just 0. So let's look at these examples. We have the absolute value of 6. Well, that's the distance, so it would just be 6. The absolute value of negative 8, the distance from 0 to negative 8, is still just 8 places. Okay? And the absolute value of 0 is just 0. So what we've seen so far is that it doesn't matter if the number is positive or negative. When you take the absolute value of that number, it's always going to be a positive answer. Now let's look at some examples. So here we have the absolute value of negative 5. Well, the absolute value, we just talked about this, is always positive, so it would be positive 5. Okay, number 2, the absolute value of 24 is just positive 24. Now, number 3, we have not done this before. We haven't had an opposite sign in front of an absolute value sign. So here's what you're technically going through. You're saying, okay, the absolute value of 12 is 12, positive 12. And then you say, what's the opposite of positive 12? That would be a negative 12. So I'm going to show you an easy way to remember this in just a second, but let's get through these examples. Now look at number 4. If you're starting to fall asleep because these videos are boring you to death, you may think that this is absolute value because your eyes are crossing because you're tired. This is just parentheses. This is just an opposite problem. The opposite of negative 6 would be positive 6. So be careful whether the lines are straight up and down or whether they're curvy, parentheses. It's two totally different operations. So you have to be very careful when you're doing these problems. Look at number 5. This is also not absolute value. This is just an opposite problem. The opposite of positive 9 would be negative 9. Okay? Now, look at number 6 here. We need to compare number 6 to number 4. Number 4, we were just finding the opposite of a negative number. No big deal. But number 6, we're finding the opposite of an absolute value. Remember, absolute value is always positive. Okay? So the opposite of something that's always positive is always going to be a negative. So yes, that's confusing. Here's what you need to remember for absolute value. If there is no sign out front, okay, then the answer is always positive. It doesn't matter what's on the inside. It doesn't matter if the number is positive or negative. I can't make a plus sign there. Now I just made a mess. Okay, now if there is an opposite sign out in front, okay, of the absolute value, it doesn't matter if the number inside is positive or negative, the answer is always negative. So the place where your sign of your answer is on the outside, okay? That's what you want to remember. The sign of your answer is outside. That's the key, and it's going to make it a lot easier. All right, so here's some for you to try. Pause the computer and try these, and then I'll go ahead with the answers. All right, so let's look at the U-tries. Number 1, the absolute value of 23 is 23, positive 23. Number 2, we've done this already. The absolute value of 0 is just 0. Okay. 3, is there a sign out in front? No. So if there's no sign out front, the answer is always positive with absolute value. Okay. But now look at number 4. We have an opposite sign out in front. So no matter what's on the inside, that doesn't matter. The answer is always negative with absolute value. Okay. But now number 5, that is not absolute value. That is just an opposite. The opposite of positive 82 would be negative 82. Okay? Number 6, absolute value or just an opposite? Right, parentheses, just an opposite. Okay? The opposite of negative 65 would be positive 65. Okay? Number 7. Absolute value. Look outside. That's where the sign of your answer is. So that's going to be a negative 46. Absolute value again. No sign out front. The answer is positive. Okay? And the last one is not absolute values, just parentheses. So the opposite of negative 3 would just be positive 3. So here are the main rules that you need to remember for absolute value. If there is an opposite sign out front, okay, so that's where you have the opposite sign out in front of the not the parentheses, out in front of the absolute value sign, the answer is always negative all the time. And if there is no opposite sign out front, okay, so that's where you just have absolute value, no sign out here in front, the answer is always positive. So this one up here with the sign out front, the answer is negative. No sign out front of the absolute value, the answer is positive. And that should be it for section 1.1. So you can now practice on the homework and quiz.